Hello everyone, today we'll be demonstrating Ansible and showing you what kind of applications Ansible can be used for and how to get up and running with your own installation. Ansible is a simple but powerful IT automation platform capable of simultaneously deploying, updating, and configuring software on any number of hosts. Ansible is unique in that it operates in a so-called agentless manner, requiring no special daemons to be installed on the managed hosts. Instead, it is typically configured to use OpenSSH in order to access and manage the target machines, though several alternative authentication mechanisms exist to suit your individual needs. As such, it is entirely decentralized and is capable of being deployed quickly and easily from almost anywhere. Ansible is comprised of functional units called modules, each of which provides some particular functionality, and playbooks. These are the simple scripts written by a system administrator to combine and make use of modules in order to perform a task. Unlike typical shell scripts used for common administrative duties, Ansible is idempotent, meaning the state of a system is not modified unless it is necessary to do so. Ansible's simplicity makes for a particularly easy installation, requiring only a Unix-like operating system with Python 2.6 installed for the control machine and Python 2.4 or better on each managed node. Several packages are available from the Ansible website that run on Fedora, CentOS, FreeBSD, Mac OS X, and others. Here we will be demonstrating installation on an Ubuntu system using apt-get. Alternatively, Ansible may be run directly from its Git source repository with no installation or root privileges required. We keep track of the hosts we manage using Ansible in simple text files called inventory files. These files are structured in a format very similar to an initialization file, where groups are distinguished by headers, with the names of hosts and other groups appearing beneath them. Here we see a very basic inventory file that makes use of address ranges and some so-called behavioral parameters. For example, we have given the machine whose IP address is 192.168.1.1 the alias of web server. Several behavioral parameters exist, capable of specifying varying items such as host-specific usernames, SSH ports, private key files, and other things. Ansible creates a default inventory file located in /etc/ansible/hosts, although you will likely maintain your own external inventory files which can be specified on the command line. It's also worth mentioning that Ansible is capable of pulling inventory dynamically from cloud services. Ansible operates in either one of two modes: ad hoc mode, which consists of executing individual commands by hand or using playbooks. Configuration files expressed in a human-readable text format called YAML. The first step in getting familiar with Ansible is to explore some examples using ad hoc mode. First, we'll look at a simple ad hoc usage for restarting a service on a target machine. When running in ad hoc mode, we usually need to provide a couple basic parameters. -M specifies the module we want to use, and -A specifies the arguments we want to pass to the module. The exact arguments you supply here will obviously vary from task to task and module to module, so it's useful to have bookmarked Ansible's documentation website for future reference. Here we want to restart the SSH service on a machine we're calling web server. The arguments passed to the Ansible command when running in ad hoc mode will typically consist of a host pattern, a module name, and any applicable module arguments. In this example, we provide a host pattern web server, which corresponds to a single alias from our inventory file. Ansible modules return data by printing JSON formatted output, which can be seen here indicating that our command was successful. Although we can perform simple tasks quickly and easily using ad hoc mode, the real power of Ansible comes from building scripts capable of executing many ordered tasks or enforcing system states. Ansible playbooks are written in a simple data serialization format called YAML. We can execute a playbook by simply providing the name of the playbook file to the Ansible playbook command. Ansible will then carry out each task in sequence, performing one task on every target machine before attempting the next task. If any failure occurs on a target host, that host is taken out of rotation and will not be contacted again for the duration of the playbook. User-defined variables can be specified in the vars section and may be referenced using the format you see on your screen within the playbook. We'll talk about this more in a bit. A useful feature unique to playbooks are handlers, which enable a playbook to respond to change events that occur during execution. We first create a list of notifiers for a task using the notify heading, beneath which we specify the names in order of the handlers we wish to invoke when a change is triggered due to that task. Elsewhere in the playbook, we define a handlers section that consists of the tasks we enumerated in the notifier list. In this example, we have defined a handler that will restart the DHCP service after updating its configuration file. It is worth mentioning that regardless of how much a handler is invoked, it will only execute once upon completion of the entire playbook. For this reason, handlers are most often used for rebooting systems or restarting services. As you can see from the output of the Ansible playbook command, the replace DHCP config file task was successful and yielded a change on the remote system. As such, the corresponding restart DHCP handler was notified, causing the remote host DHCP service to restart. If we were to immediately rerun this exact playbook again, Ansible would report that no change was made during the file replacement task, because at this point the remote host version of the DHCP configuration file matches our local copy. Consequently, the restart DHCP handler did not execute, as there was no need to bring the DHCP service down. This example illustrates the idempotent property of Ansible. In our next video, we will delve into using loops and conditions to write richer, more complex and reactive playbooks, and we'll discuss what Ansible roles are and how we can use them to our advantage. Thanks for watching.